All right, listen. Let's listen. Let's sit forward. Look forward. Okay. Now, before we get started today, okay, on Monday, do you remember what we talked about?
Yeah. We talked about
We talked about, okay, yes, we talked about triangle congruence. Now, when we talked about triangle congruence, there was 5 different ways we can prove a triangle is congruent. Raise your hand and give me one of them. SAS, ASA, HL, no. AAS, and what's the last one? SSS. Okay. So remember, S stands for side, A stands for angle. What did HL stand for? Yeah, hypotenuse leg. Okay. So we're going to be using these, okay, today. All right, because it's going to help us, and this is going to be the end of like our proofs. Okay. So this is what we have to get. So when we're given a triangle, all right, we'll be given this at the end, all right, and we have to find the sides or the angles that are congruent. You won't really see that many with hypotenuse leg, but just know the point of that hypotenuse leg is that hypotenuse needs to be congruent in just one of the legs, all right? And what made the hypotenuse the hypotenuse? Yeah, it's the longest side. It's across from the 90. It's like the diagonal side. Okay? Now, there's a couple things that we need to go over before, all right? And these should all sound like review, all right? Does anyone remember what the reflexive property does? Yeah, she raised her hand, so we're going to listen to Rebecca. No, that's not reflexive. What? Sure. No. If we had a variable. So, yes, it would be if something equals itself. That was what the reflexive property. Because we had like, if x equals x or b equals b. All right, this is what we're going to see with the triangles. Now, if I have a triangle, all right, I have this triangle right here, all right, and this triangle right here. Okay, now, what can I notice about these two triangles, all right, they share a side, okay? So this would be an example where we can say something with reflexive properties. So if I name each of these vertexes, let's say that's A, that's C, this is B, this is D, okay? We can say for these two triangles that these two sides are congruent. So AD is congruent to itself. So AD is congruent to AD, all right, because of reflexive property, all right? Because it shares that side, so we can say that they are congruent to each other. So I'm just going to put one congruent mark, all right? And then let's say we had this angle was congruent to this angle, all right, and then these two sides were congruent, all right? Which of the triangle congruence would this be? Side, angle, side. Okay, we have two sides, and the angle is in between. All right? So that... Mm-hmm. Mm-hmm. Okay, so that's with reflexive property, all right? Does anyone remember anything about an angle bisector? So let's say, again, I have this triangle right here, all right? Well, not quite. Okay, we're going to be talking about angle bisectors. Now, if you have something, and let's say it says segment AC, okay, bisects angle BAD. Okay? We have to figure out what can be congruent when AC bisects angle BAD. Now, when it bisects this angle of A, so angle BAD, all right, what happens to these two angles? They're congruent, okay? So we can say that those two angles are congruent because when we have an angle bisector, it bisects it directly in half, all right? So it bisects it directly in half, and that would be an angle bisector. Now, let's say I have the same image, but let's say segment AC bisects segment BD. What would happen for BD if it bisects that whole segment of BD? It doesn't have to necessarily go through. So what would be congruent? Yeah, if AC bisects BD, that would make BC congruent to CD. So that would result in BC being congruent to CD. This is a segment bisector. Okay. Uh-huh. Yes, so it would make yes, angle BAC is congruent to angle. Yes. We won't necessarily have values, but it's good to know that's what happens with the values. Okay? So there's how you could say those two angles are congruent. Okay. This ring a bell? Let's say A is parallel to B. All right. Who can tell me a pair of alternate interior? 3 and 6. And also 5 and 4. We'll have some of these in here, but mostly just alternate interior. Okay, now, biggest thing that you need to know, okay? A is parallel to B, all right? This line right here that I'm drawing over, can you see that? All right, this is that transversal, all right? And we'll see some examples with that. But just know, if it's alternate interior, what can we say about the two angles? They are congruent, okay? Perfect. No. All right. Just move your notes to the side, okay? All right, and I want you guys to be able to see what we're working with, okay? So this is like your new notes right now, all right? But these are all the examples that we're going to be going through. But it's important to have those notes next to you so you remember what that reflexive property does. Those alternate interior, and those 4 behind you. You still have your extra credit.
I know. My dad's like, Sophie, you're literally not doing it right. I'm like, I'm doing just fine. And I'm like, I got extra credit. I had a dream where I had all B's and I almost cried. Like I almost cried like while I was asleep.
Do you want me to make your dreams true?
No.
Just kidding.
Yeah, I will. Are we like?
All right, don't work on anything yet. Okay, we're gonna do these together. All right. How does that look on the screen? How would this be?
It's like you should have the bottle. It's like okay, that's better. That's better. That's good.
All right. Okay, we can actually see everything. I'm going to do blue though. Okay, here's what we're going to pay attention to, okay? These are what our proofs are going to look like, okay? So it doesn't look like our statements and reasons column, okay? But this is doing the same thing as that statements and reasons. Everything above, see how you can see the word reason? Everything above that is the statement, all right? So if you look at these, we are given all the statements. We just have to come up with the reasons. All right? And then eventually we'll have to come up with the reasons. Then we'll have to do both. But we're going to start with just this, and we're going to repeat a lot of these questions because if you look at them, a lot of them are going to be similar, and you do those same steps. Just the triangles look a little different. Not quite.
Oh wait, we didn't have to do the reason.
Is it on Delta Map?
This is different. This is different from Monday. Monday, you were naming the sides, you were naming the angles, and saying the triangle congruence. All right? Now, we're going to be doing like we're proving. Okay? So, let's go ahead and look at this first one. So, always read the top. All right? And I know the top doesn't give us anything on these, but eventually the top will give you stuff. So, this just says, based on the given diagram, complete the flowchart proof below. You always need to look at the image. Because does it have anything on those triangles? It has some lines. And what do those little lines mean? They mean congruent. So let's go ahead and let's look at our first statement. It says AD is congruent to CD. Now, let's look at the triangle above. Does it show us that those two segments are congruent? Yeah, so if it shows us that, does anyone have an idea of maybe what my reason is? It's just given. We're still going to have givens.
I like that.
Let's look at the next one. AB is congruent to CB. Look at the triangle. Does it show us that? Yes. So what's our reason? Given. Okay, look, we already have 2 of the 4 boxes filled out. These are the parts that everyone forgets to do. When I did this last year, everyone was missing this because they didn't do the givens. They tried to say reflexive property for this. Well, it's not the same thing. This is not the same thing. Okay? Because when you do this, luckily you don't have to come up with your own answers. You have like a multiple choice options. Okay? When you do it on the Delta Math. But when you get your quiz or test over this, this is what it'll look like on paper. All right? Where you're not given those multiple choice, you have to come up with those reasons. Okay? So let's look at the next one. All right? BD is congruent to BD. Does it show us that on the image? No. Okay? So we need to figure out why that's congruent. Okay? Well, if it says BD is congruent to itself, what did we talk about earlier on what we do? Yeah, reflexive property. And if you look at the image, it's that same line. So before you write reflexive property, go on that triangle and mark that it's congruent. Okay? I recommend doing it every time so you can visualize it. No, but I would just recommend because it makes your life easier. Okay, perfect. Now, this next part, we're saying triangle ABD is congruent to triangle CBD. Okay? When we look at this, there's 2 different ways you can do this. You can look at the image and figure out what triangle congruence it is, or look at these boxes. All right, is this a side or an angle? Side. What about this one? This one? And then if you look at the image, do we all have sides? So which of my triangle congruence is this? And there you go. Side, side, side. Perfect. Try the next one on your own. Try the next one on your own. All right, and use that proof that we just did. Look at the image, mark what you figure out, all right, and then come up with that triangle congruence. All right, and I'll check back in a minute. All right, and then just stay on that page. See, not too bad. Not too bad.
Oh, that's easy peasy. I think it's kind of simple. Like I can understand it. But then like last.
Yeah.
When we first did it, I was like, it's more visual. Okay, like
Yeah.
so my Latin quiz was a 91, then I got a 75 on a quiz, and it went up to a 97.
Then that just means you did bad on your first quiz.
I did.
Do you finish this one? That's not the right reason. No. Then go to Colby. All right, let's stop talking, okay? And let's go over this one together, all right? First thing that I need to look at, okay? On the top, it just says, based on the given diagram, complete the flowchart proof below. Okay, it says, my first step, angle BAC is congruent to angle DAC. I look at the triangle, is that already marked? So what can I say? Given. Perfect. All right, again, look at the next one. Angle BCA is congruent to angle DCA. All right, is that already marked? So what can we put? Given. All right, good. We already got 2 of the 4. Now, I look at the next one. It says AC is congruent to AC. So if something's congruent to itself, it is reflexive. Yeah. And this one does make it tricky. Okay? Because this one, the boxes don't follow it. Okay? But that's because it did the givens first. All right? On this one, all right? Even though those first 2, all right, listen. All right, stop talking. Okay? Even though the first 2 are angles, okay, and the last one's a side, all right, this is not AAS. All right, so if you had AAS, go ahead and erase it. Okay, now, if you look at the third one, this is why it's important to mark the triangle, okay? We said AC is congruent to AC, so I'm going to mark that. Now, I have 2 angles in one side, okay? But when we look at the angles and we look at the side, is that side in between the 2 angles? So then which one does it have to be? ASA. Because that side is in between. Flip to the next page. Because it looks fun. I love bow ties.
I had a teacher who wore a different bow tie every day for 3 years. That's not me. Then he got fired. He had a girl in the. He had a guy in the clipboard, and then they sued him. Yeah, no, you just don't like when you wear a bow tie. You have the hair for it, I feel like.
No, I never wear a bow tie.
No, I don't know.
I was thinking bow tie pasta. Okay, listen. Now we look at these. These look a little different because it's got that extra box. Okay? Now, the extra box is actually going to help you out a little bit. All right? First thing that we need to look at, though. Okay. On top, it actually does give us something. So it says given AB, and what does this mark tell us? No. Parallel. AB is parallel to DC. Complete the following proof below. Now, if you are given something on top like that, then typically it's going to have an extra box above the 3. Because when we have those 3 by each other, so like these 3 by each other, then those are going to be the 3 letters that represent your triangle congruence. So those 3 boxes on the bottom to get to that very last are going to represent that triangle congruence of like ASA, SAS, okay? Now, it just involves an extra step, okay? But biggest thing is, if it says AB is parallel to DC, okay? Then I am going to mark that. When you're marking that 2 sides are parallel, you're going to put like this arrow. And that tells us that they are parallel. Does that mean they are congruent? No, it does not mean they're congruent. All right? In this case, it does tell us that they're congruent, but we'll get to that in a second. Now, if AB is parallel to DC, all right, and that was given above, all right, that is our given. Okay? Now it has two arrows to those next two boxes, all right, and it tells us that AC is parallel to, what am I saying? Sorry. Angle A is congruent to angle C, or it says angle B is congruent to angle D. Now, luckily, that first box gives us our reason. Okay? Am I going to have you write out that whole thing? No. Okay? But you need to understand what it says. So, luckily, let's look at angle A is congruent to angle C. All right? It says the reason is parallel lines cut by a transversal form congruent alternate interior angles. Okay? If you just put alternate interior angles, that's fine. So you could just put alternate interior angles, all right? But let's look at this. So I'm going to mark my angles. It says angle A is congruent to angle C. So I'm going to go ahead and mark those, okay, because we know that they're congruent, all right? But why does that work, okay? Now, if we look at this, if we're given two parallel lines, right? So in those triangles, okay? If I were to flip these two triangles, all right, and make it look like this, okay? These are my parallel lines. Sorry. All right, and we just said that these two angles are congruent. Okay. This is just like that angle transversal that we were talking about. These are the two parallel lines. All right, and this is that line of that transversal line. So if you can see, these two angles become alternate interior angles. All right, do we see that image now? It's just like this. All right, and we're just saying that this angle is congruent to this angle. Okay? Now, if you look at the next one, it says B is congruent to D. So I'm going to go ahead and mark those angles, and I'm going to put 2. Okay, so it shows us that B is congruent to D. All right? And if we look at the image over here, this is the one I'm going to be talking about. That's going to be this angle, all right, and this angle. Are those also alternate interior angles? They are. So you would end up doing the same exact reason. Now in delta math, it's going to have this whole thing, okay? But whenever you write it, you can just put alternate interior angles. Okay? You won't type it, you just select it. Okay? Does that make sense? Okay, I'm going to erase all this. But I just want to make sure you guys can visualize that. Yes. Say that again.
Isn't it cute? Where would these two be located?
This one and this one.
Okay, so this one has a different transversal though, because it's like this.
Yes. So yeah, if you notice, cut it out. All right, or I'm going to make you move. All right. If you notice, okay, BD does have a different transversal, but it's still doing that same thing. All right. It has a different transversal, but it's the same parallel lines, so it still works. Okay. All right, you can still see your image, but on my screen, we're not going to be able to see the image anymore. All right. Next, it says AB is congruent to CD. How do I know that? It's what? It's given. Look at the image. Does it already tell us that those two are congruent? It does. So that's just given. Yeah. Now it's time to prove that the two triangles are congruent. Look at where your angles, look at where your sides are. Which of these triangle congruents is it going to be? Let's say it together. ASA. Yeah. Cooper said it. But Is that side in between the two congruent angles? It is, so that's why it's ASA. Okay? Because A, S, A. Perfect. Let's look at the next one. All right? We're given the same given. This says AB is congruent to DC. All right? We need to complete the following proof chart below. Okay? This time, all right, we don't have two arrows, we just have one. All right, AB is parallel to DC. I'm going to go ahead and mark that. So let's go ahead and mark that. And what do I mark it with? Yeah, a little arrow. So I'm going to go ahead and do that. AB is congruent is parallel to DC. It's up here. I'll move up in a second. Okay. Use that image above, okay? Now it says BAC is congruent to DAC, okay? So I'm going to go look at the image. So let's mark those two angles because it already tells us. So BAC is congruent to DCA. All right, and I'm going to put two congruent marks because there's already a set of congruent angles. Okay. Now, anyone have an idea of how do we know that those are congruent? Yeah, this is going to be the same exact reason as the last one. The parallel lines cut by a transversal form congruent alternate interior angles. So again, look, we have our two parallel lines. We have this transversal. That's what the image is right here. Okay? All right, and it's just this angle right here and this angle right here. So what kind of angles are those? Alternate interior. So that's going to be our reason. So alternate interior angles. Perfect. Now let's look at the next one. All right. BCA is congruent to DCA. Let's go ahead and mark it, but is it already marked? Or DAC, thank you. I'm sorry. It's given because those are already marked. Perfect. Now we look at our next one. AC is congruent to AC. If something is congruent to itself, what is it? Reflexive. Yep. Thank you, Maddie, for saying that. Because I was about to say it. Okay, because we've already done that 4 times. All right. Now let's look at the image. Look at the image. We have two congruent angles, one pair of congruent sides. Okay, is that side in between the two congruent angles? So which one is this? Again, it's ASA. They're not all going to be ASA. Do we have any questions on these first 4? Yeah. Eventually. But those are the main ones, and that's why I'm focusing on those right now. Yeah. Yeah, pretty much. All right, let's go ahead. Flip the page to number 5. And do number 5 on your own. Do not do number 6. We have not done one like that yet. Pay attention to what it gives you, and you guys can figure this out. See it, Maggie. Number 6 is where, this is where we're going to get some new stuff as well. All right, I'll give you a minute or 2 to do number 5. Done? Nope. Something's wrong. You have 3 of the 4 boxes right. One's wrong. One of the boxes is wrong.
Wait, which one's wrong? Which one do you?
One of your boxes is wrong too.
Yep. What about mine?
Perfect. You're not even done.
Yeah, I know, but you said one of my boxes.
No, I was talking to Crocker.
Oh.
What's wrong? I don't understand.
We won't ever do alternate exterior. And then your last one's wrong. It's your last one. There you go. Good. Pay attention to like the order it goes, and then mark your side to help you.
Hey, look at mine. Okay, don't look at that. Is it right?
Yeah, but did we ever say angle, angle, angle is one of them? You know?
Angle, side angle. How about that?
Eh.
Okay, side angle, side. Yeah, exactly.
No, it's not. It's not though.
Is it a
Yes.
why?
I'll explain in a second. Yeah, that's better. Steven. Do we call Steven or Steve? Okay.
You stole my coffee.
Yeah, we'll go over it.
I did not copy you. You copied the
Eh.
First, you could have just
Eh. It's not. It's not ASA.
So wait, how do I find it?
We're gonna go over it.
Angle? How do I find it? Order.
Well, and I'll show you on this one. All right. All right, let's talk about this. What does it give us on top? Like, what does it tell us on top? No, it does not tell us they're equal. No, they're not congruent. They're parallel. It tells us AB is parallel to DC. Okay, so let's go ahead and mark that. I'm going to mark AB is parallel to DC. Okay, with those arrows. All right. Now, that's our given. Okay. Now it says, let's go from follow our arrow. It says angle BAC is congruent to angle DCA. I'm going to go ahead and mark those. BAC is congruent to DCA. All right. Who can tell me why those are congruent? Yeah, Julian? Those are alternate interior. Yes. Because these are already marked. Perfect. Now, next one. It says angle B is congruent to angle D. All right? We look at the image. Does it already tell us that? So what is it? Given. Perfect. Next, AC is congruent to itself. That's reflexive property. Perfect. Now, here's where half of you were getting it wrong. Okay? It is not ASA. Okay? It is the side in between the two sets of congruent angles. It's not. Because see how this is one of the angles? This is one of the angles. So that means the congruent side would have to be here and would have to be here for it to be ASA. Whenever you start, okay, the 1 dash or 2 dash don't matter. You can start with either the side or the angle, okay? And you just have to follow the way it goes. So if I choose, all right, if I end up choosing the side, okay, I'm going to go up here. So I have S. What do I get here? No, A, and then here. A, okay? Is there an SAA? But if we flip it, what is that? AAS, okay? Angle, angle, side. Angle, angle, side. Now, those other ones, like if you have side, angle, side, okay? Well, if you flip it, that's the same thing. If you have angle, side, angle, if you flip it, that's the same thing. Side, 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 if you flip it, it's the same thing. All right? Angle, angle, side is the only one that it's a little tricky. But just follow the direction it goes, okay? And you have to go follow the congruent symbols. You wouldn't be able to go from D to here because there's no congruent side or a congruent angle. All right? So you would have to follow, all right, where that next congruent symbol is, and then do the next one after that. Does that one make sense? So if you get side angle, angle, just flip it, and that's one of the ones we talked about, angle, angle, side. Okay? So what you should have done right here, angle, angle, side. Does that make more sense than the angle, side, angle? That side is just not in between the two congruent angles. Okay. All right, let's look at the next one. Okay. Next one, all right, we have an additional box. Okay, but let's look at the given. It says, we're given that AC bisects angle BAD and angle BCD. Complete the following flow chart below. Okay, if we look at our triangle right here, we're not given any congruent symbols. Okay, we have to figure out all three. So let's look at our first two boxes. Okay, let's look at the first one right here. All right, it says AC bisects BAD. All right, and that is given. So now let's look at the box below that. Follow the arrow. It says angle BAC is congruent to angle DAC. So I'm going to go ahead and mark those two angles. Okay. Just so you can see the difference. You could, okay, so the only reason, if you do this with your angles when you mark them, that's fine. All right, I just don't want you to, I do them separate so then I know those are two different angles that we are talking about. Okay? This box. It says BAC, they turn the heat on. I can't put cold air anymore. Okay, AC bisects BAD, all right? And then we got angle BAC is congruent to angle DAC. Okay. Now, what is a bisect? What does that mean? And when it bisects, it cuts it in half. Okay. So, when it cuts in half, all right, we have to explain what that means. All right. This is what it's going to say on Delta Math. An angle bisector divides an angle into two congruent angles. Okay, is what's happening? So this is what I want you to do on these. You're just going to put definition. So I'm just going to put DEF of angle bisector. Okay, so you can just put definition of angle bisector. Julian, put it away. Let's look at the next box, okay? AC bisects angle BCD. All right, follow the arrow. We now have angle BCA is congruent to angle DCA. Now, is this the same thing on what happened below, or the previous one? Yeah, so what is my reason going to be? Definition of angle bisector. You're going to put the same thing. Okay, perfect. Now, we have AC is congruent to AC. When something's congruent to itself, what is it? Reflexive property. Perfect. Going to go ahead and mark that. Now, when I look at my two triangles, what triangle congruence is that? ASA. Perfect. Let's move to the next page. Do 7 and 8 on your own.
There's more? I thought we were on the back page.
No. You can mark them yourself.
What was the ASA?
There are so many.
Wait, Mr. Are we doing the whole packet?
Do 7 and 8 on your own. All right, do them on your own, and then I will show you the answers in a second. No, just 7 and 8. Do 7 and 8. Oh,
Oh wait, hang on. Oh, I thought you said it V.
no. Mark all of them. Mark all three. That'll help you. Can you flip to the next page for me? Okay, thank you. And you're given the very bottom, right? Okay. Mhm. All right, take another 30 seconds to finish up, and then I will show you the answers. And if you got questions, raise your hand.
We're gonna do it on our own, like actually on our own.
And then eventually you won't even see this box.
No.
See, that's why we're doing a lot of it together.
I don't like.
I know I am.
Are we finishing the whole thing?
Yes. All right, here are those answers.
I thought I had this, but like I didn't have that. But like I thought I had.
Well, yes, it looks difficult, but it's easier than you think.
It's easier than not this early in the morning. Which one? Like the grass. Like this?
They can, but once you just keep doing them, then you're like, oh, it's this one again. Then it has to be those.
So we always do the definition, right? Because we don't have any numbers, and like that's just what we can like take away from it.
Yeah, because these are proofs. We're not proving. We're not answering. Well, we're not solving, but we're showing the steps.
If like it had numbers or something though, would that just be a bad thing?
Yeah, like if it was angle 50 and it was an angle bisector, what are your two angle values?
Wait, sorry, 50 and
Yeah, so each of them are 25. Well, we'll have more angle bisectors kind of with like polygons, mid segments next semester. All right, does anyone else need these so we can move on? All right, go ahead, flip to number 9. Oh no, what did I do?
Oh, so like I wanted to use like this one.
Yeah. We're going to do these together. Well, that's why we're doing it together. We're gonna do it together. I know you want to figure it out, but you can figure out the next two when I give you those. All right, what is different about this one compared to the ones we just did? Yeah, we pretty much have to find out all the information, but what are we given on the very bottom? We are told what the triangle congruence is. Okay? So we know, okay, if this one's AAS, we need to have two sets of congruent angles and then one set of congruent sides. Okay? Now, biggest thing you have to pay attention to is always pay attention to your given above. This is, given BD bisects angle ABC, all right, we have to complete the flowchart below. We have to have the statements and the reasons. Now, pretty much every time that it gives you something up here, you're going to put in those extra boxes above with those arrows. Okay? So we are told that BD bisects ABC. So let's put that as our first statement. Because remember, we always put our given as our first statement. So BD bisects angle ABC. All right, and what's my reason? Given. We're given that above. Okay, perfect. Now, we look at BD and it's bisecting ABC. That's this whole angle right here. Now, when it bisects, what happens? When we have BD that bisects the angle, what does it do? It splits in half. So let's go ahead and mark those two angles. Okay, because they both have to be what? They have to be congruent. So, someone raise your hand and tell me the name of these angles. No. Angle ABD is congruent to angle CBD. Okay? That's CBD. Okay, then I'll have you answer in a second. Now, do we see how we got those angles? All right, pay attention because you got to name them in the correct way. All right, see how we did A, B, C? You need to do the same thing on this triangle, C, B, D. Don't do D, B, C. All right, if you did D, B, C, it would need to be D, B, A. Okay? Because remember we had to follow the order of the letters? All right, it's the same on these. Now, Julian, what's our reason for this? Perfect. Definition of angle bisector. Okay? And here's one thing that maybe it might help you out. Okay? I'm going to put an A. Okay? Because we just named two angles that are congruent. Okay? So that's one of my letters. All right? Because I want to make sure all three letters match my three letters on the bottom. Doesn't have to be in that correct order necessarily, but it needs to have two angles and a side at least. Now, let's fill in our next boxes. Now, when you go to our next boxes, what's the first thing that we need to do when we look at the triangle? We need to look if anything is marked.
Yeah, they are.
There's stuff that are marked, so let's see. Is there any angles that are marked?
Yeah. A, B,
So let's name them.
angle A, B, B is congruent to angle C.
Perfect. And I'm sorry that I wrote over that. I'm just trying to write a little bigger. Okay? And what is our reason for this? Given. All right. Thank you. Okay? Now, that's another angle, so I'm going to put an A below. Now, are there any sides that are congruent? AD is congruent to CD. Or DC. Is it already marked?
Wait, are you supposed to write a line of them?
Yes, but I'm not going to be too picky on that.
Wait, why is the CD in that size?
The segments, it doesn't really matter. The angles you need to pay more attention to. Okay, and then these are a side. Now, do I have two angles and a side? Perfect, so that matches my AAS. It doesn't matter which way you did it. But if you look at the image, it is AAS, so that matches. All right, let's do the next one together. All right, what does it tell me on top? Okay, this time we have segment bisector. I can't move up for some reason. Okay, but just know it says on the top of your paper. Now, we have a segment bisector. Okay, so I'm going to go ahead, all right, and that's going to be my given. I'm just going to put BD bisects AC. Okay, and what's my reason for this? Given. Now, what happens when we have a segment that bisects another segment?
Wait, so you're saying that this box is the same thing as written above? Yes.
So, if BD, this segment, bisects AC, all right, what happens? AC is cut in half, all right? So, what does that tell me about our two sides? They're congruent. So, I'm going to put, listen, I'm going to put AE is congruent to EC. And what is my reason for this? This is definition of, pay attention here, segment bisector. All right? Angle bisector and segment bisector are two different things. So pay attention to that because you will miss the point if you put angle bisector here. Is this talking about angles? No, it's talking about segments. Okay? All right. Let's look at my triangle. Are there any angles or sides that are given? All right. We're given angle A is congruent to angle C. What's my reason? No. Given. All right. Are angle B and angle D marked as well? So what does that mean? It's given. And is that angle side? But if you flip it, it's angle side. Yeah. But it's not necessarily going to match. So just know that's when you can flip. Try the next two on your own. You're not lost. You got it. No. All right, guys. Work on these two on your own. All right, I'm going to write the answers so you can pause the video. Oops, I forgot this one.
Because I feel like these would switch like the side and the side, right? So it'd be like CD. Well, not the side, that's the other one.
Okay, you're so close. You need to. So, okay, first of all, you cannot name this angle C and angle A because there are two angles.
So like BAC?
And DCA. Now, when this one is parallel and this is given, right now you're talking about two segments that are congruent. So these need to be flipped. Because the reason, if we're given that these are parallel, this is the reason why it's alternate interior. So that's why these have to be under this. Does that make sense? Because you cannot have two givens in a row. Always remember that. No two givens in a row. Yeah.
We can do a bivalent. Oh,
These are clean, by the way.
that's true. Yeah.
We're not given that D is congruent to B.
They are.
What do you mean?
Oh, hold up.
We're given something else.
Oh, BC and BA.
No?
Yeah, they are.
Is this BC?
Oh, that's BA.
And then, oh, did you say DC? I heard BC.
Yeah, I think I said that, but I wrote.
Okay.
The given.
Yes.
Wait, it's angle.
Again, you need to make sure you draw the angle mark. No, like on these. Because you're just saying D is congruent to B. You need to tell me it's angle
Oh, okay.
on this. Then I think that's fine. You're not even done. Oh. Make sure you mark your angles in front. Put angle. Yeah.
Am I right now?
I think so.
I did any of this work.
You'll be able to check in one moment.
So I was wondering.
Why'd you mark the whole angle?
Oh, what?
Okay. All right. I need everyone to listen because I've caught this on a couple people's. All right. This first box right here. What are we putting in our first box right here? It's the given. Now, when we have a parallel lines, and this is given, you are not going to put a given below that. This arrow is telling us that it goes with this given. So when we're given that two lines are parallel, that's going to go with our alternate interior angles. All right? That has nothing to do with our segments being congruent. So you're not going to put your given here. All right? All your givens need to be separated into the other boxes so the arrows do not go together. So you should never have two givens in a row. Just erase it. You cannot have two givens in a row. This can't be given and this can't be given. But I just told you, two givens cannot be in a row.
So can I put that?
No. This is in the wrong box. These are only angle bisectors because these two lines are parallel. It would not, or those, sorry, the alternate interior. I said,
I'm already doing it.
wait, no, does it say anything about an angle bisector?
No.
No.
So it doesn't have to be. It doesn't. So wait, no angle bisector?
It's only an angle bisector if it tells us that.
Okay, so this is not an angle bisector.
Correct.
We can't.
Yeah, we can't assume that. But if two lines are parallel, then that tells us two angles are alternate interior.
I'm gonna need like
If well, it can help, but if these two lines are or parallel, then we know that two angles have to be alternate interior. Okay? So if these are your two parallel lines, and we have this right here, okay, then what two angles is it going to create? Well, yes, it's C and A, but you have to be more specific because it can only be half of this angle. So it's going to be this one right here. DC, is that A? DCA, and what's the other angle? All right, if you are done, check your answers. All right, and then we are done.